Alrighty, let's talk about some exponential equations here and how to solve. This is an example of an exponential equation. The x, the variable, is actually in the exponent, which is what makes this different than other types of equations. In this question here, we're being asked to solve for the unknown. It sort of looks to me that x is just going to be 3, right? And that's the principle of this, right? 3 is the exponent and x is the exponent, so they must be the same, right? That's the idea here. If we have the same bases, if the bases are the same, the exponents must be the same, right? 2 and 2 are the same base, x and 3 therefore must be the same because there's this equal sign that tells us the left side and the right side are the same. Now we cannot just jump to this whole x equals to 3 business. We need to use the symbol. It's like an arrow that has 2 lines in it, and what it means is implies that. We need to use that in order to show the step that we're jumping to, okay? So this is how my answer would look. I would have my x is equal to 3, but then I would draw this little arrow either before I even write my answer or after, and it's actually just going to go underneath. Okay, so we have the implies that, and then we're able to come to our conclusion when we can just sort of ignore the bases. Some students think of it as like the base is being canceled out, which is a perfectly good way of thinking about it. So let's do some light examples here. 3 to the power of x is equal to 3 to the power of 8. My bases are the same, so my exponents must be the same. This implies that x is equal to 8. Okay, in our next question here, I have 4 to the power of x is equal to 4 to the power of 2x minus 3. My bases are the same, so I can jump to setting my exponents to be the same. X equals 2x minus 3. Now I can rearrange, right? Now this is turned into a linear equation. So I'm going to bring my 2x to the other side and subtract it. I'll combine my like terms here. Negative x is negative 3, so x is equal to 3. The only time I need to write the implies that step is when I get rid of the base of my exponent. You don't need to write it every single time. Here's a bit more of a challenging one. 2 to the power of x is equal to 4. These don't have the same base, but is there a way that we could write it so it's the same base? Think about it. 4 is actually 2 to the power of 2, right? So what if we were to write our question like this? 2 to the power of x is 2 to the power of 2. Oh, this works out nicely. Now look, I've got 2 bases that are the same, so my exponents must be the same. X must be equal to 2. Okay? That was sort of a more challenging one, but essentially, that's where we're coming from here. When the bases aren't the same, we need to use power laws or exponent laws to set them as a common base and then solve. Okay? We'll do a couple of questions like this. Here's our first one. 4 to the power of x plus 1 is equal to 2 to the power of x plus 1. Well, we know that 4 is the same thing as 2 squared. So I'm going to write 2 squared, and then all of this is to the power of x plus 1. This is like a double exponent, right? X to the power of 1 is actually higher than the 2, and so our power laws tell us we need to multiply these two together. I'm going to distribute the 2 out. And now I have same base, my exponents must be equal. Implies that 2x plus 2 is equal to x plus 1. Okay, I rearrange. I'm going to bring my 1x over and the 2 over. 2x minus x will be 1 minus 2, or x is equal to negative 1. Okay. That was easy because one of our initial bases was going to be the base for the other one. But look at example B here. 9 to the power of x is equal to 27 to the power of x minus 5. 27 is not 9 to the power of something, just like how 9 is not 27 to the power of something, but they both have a factor of 3, and in fact, 9 is 3 squared, just like 27 is 3 cubed. Now we can write in the exponents that we had originally on the question. On the left side there was an x. On the right side I had an x minus 5. Now we bring those exponents in through multiplication. So this will be 3 to the power of 2x is equal to 3 to the power of 3x minus 15. I add in the implies that. I can jump to the exponents now. 2x must be equal to 3x minus 15. I'll bring my 3x over. 2x minus 3x will be negative 15. Negative x is negative 15, or x is 15. All right, pretty cool. We'll do a couple more. Here I have 1 over 9 to the power of x plus 4 is equal to 3 to the power of 3x plus 7. Okay, this is a fraction. We know we get fractions with negative exponents. So this is actually 3 to the power of negative 2. And then I add in the actual exponent, x plus 4. My right-hand side is going to remain the same. I distribute out through multiplication. This will be 3 to the power of negative 2x minus 8 is equal to 3 to the power of 3x plus 7. And now I can jump to just my exponents. This is implying that negative 2x minus 8 is equal to 3x plus 7. And I'll do some rearranging. Negative 2x minus 3x is equal to 7 plus 8. So negative 5x is equal to 15. X is going to be equal to negative 3. Okay, trick here being when it's in fraction, you have a negative exponent. Okay, question D. 4 to the power of x is equal to the square root of 2x plus 3. Okay. 4 to the power x, we're going to bring this down to a 2, just like we have before. We have a 2 here, but it's underneath the radical sign. The radical sign has an invisible 2 above it, which tells us that it's a square root. And when we have roots like this, the exponent is a fraction where the denominator is equal to the sort of intensity or the value of the root. So in this case, it's a square root. So my exponent is 1 over 2. X plus 3. We distribute out. 2 to the power of 2x is equal to 2 to the power of x over 2 plus 3 over 2. All right, jump just to the exponents. Add that little arrow. 2x is equal to x over 2 plus 3 over 2. Let's multiply everything by 2 to get rid of the denominators there. So I'll have a 4x is equal to x plus 3. Bring my 1x over. That'll become a 3x is equal to 3, or x is equal to 1. Okay, let's look at a bit trickier questions here. Okay, here we're being asked to solve 8 times 4 to the power of x plus 5 is all equal to 1. Okay, one way that you might solve this, probably the fastest way, is I'm just going to rewrite it here. What if we divided both sides by 8? Okay, this is a little bit easier. both of these bases, the 4 and the 8, have a common factor of 2, where in fact 2 to the power of something gives us 2 them. So I can rewrite this. 2 squared x plus 5 is going to be 2 to the power of negative 3, right? Because this is a fraction, and then 2 cubed gets us that 8. All right, this is nice and easy now. We can jump right to, well, I'm going to distribute out that bracket. 2 to the power of 2x plus 10 is 2 to the negative 3. And so we can jump to our exponents. 2x plus 10 is negative 3. I'll bring, keep my 2x on one side. I'll bring my 10 over. 2x is negative 13, or x is negative 13 over 2. Alrighty here. Okay, now let's look at a little bit more challenging questions here. 3 to the power of x plus 2, take away 3 to the power of x, is equal to 216. Whew. Okay. 216 is not 3 to the power of something. So we don't have a common base here that we can work with, which is unfortunate. Okay, I just want you to consider the strategy that I'm going to employ here. Okay. Would you agree that 3 to the power of x plus 2, this is an exponent law here, the addition exponent law. And you might recall that the addition exponent law happened when two numbers with the same base were being multiplied. You had to add the exponents. So like 2 to the power of 4 times 2 to the power of 6 is the same thing as 2 to the power of 10. I'm going to kind of go in reverse here. I'm going to break this down. I'm going to say, well, this must be 3 to the power of x times 3 to the power of 2. Take away 3 to the power of x equals 216. Huh. Both of the terms now have a 3 to the power of x. I'm going to factor that out. 3 to the power of x leaves me with 3 squared, which is just 9. I'm going to write 9, minus 1. Okay, what's 9 minus 1? That's 8. I bet I can divide 216 by 8. And in fact, 216 divided by 8 is 27. Haha, here we go. 27 is 3 cubed. And so I can jump to my exponent now. I can say, well, then x is equal to 3. Okay, this is a factoring strategy because we are able to break it down. Okay, let's look at another example here with 2 as a base this time. So once again, I'm going to break this term down that has an addition into two separate terms. 2 to the x and 2 to the 3. All plus 2 to the power of x is 288. Factor out my 2 to the power of x because both the terms on the left side have that. And I'm left with 2 to the power of 3 plus 1. 2 to the power of 3 is 8. 8 plus 1 is 9. And 288 divided by 9 is 32. Aha, 32 is 2 to the power of 5. And so we can say, well, then the x must be equal to 5. One last one like this style. Negative 500 is equal to 5 to the power of x plus 1. Take away 5 to the power of x plus 2. Let's go with the same strategy here. Negative 500 is, break these guys up. 5 to the x, 5 to the 1, minus 5 to the x, 5 to the 2. You don't need to write the 1 here. I'm just emphasizing the fact that this is where the 1 came from. I'll factor out my 5 to the power of x, leaving me with 5 minus 5 squared, which is just 25. So I'll just write 25. 5 minus 25 is negative 20, and I can divide both sides by negative 20 to get 25. We know that 25 is 5 squared. Now we have the same base, so I can say, well then 2 must be equal to x. Now the last thing that we're going to do here are some word problems. We're going to do 3 examples, okay? Basically, we're going to set up our equation using the information that's provided, and then we're going to solve using the same strategies that we've seen previously, okay? Here's our first example. You uploaded a funny video pranking your sibling onto TikTok and notice an upward trend in views. On the first day, only 8 people had viewed it. On the second day, 64. On the third day, 512. TikTok defines going viral as reaching over 250,000 views within the first week the video was posted. If your video follows the same trend, will it go viral? Let's take a look. I'm going to start this one off by creating just a table of values to record some of the numbers that I've been provided. X will be the number of days, and Y is going to be the number of views. On the first day, 8 people had seen it. Second day, 64. Third day, 512. It looks to me like we're going up by 8, right? 8 times 8 is 64. I'm just going to double check. 64 times 8 is equal to 512. Okay, so what we're actually working with here is exponents, where we have this is 8 to the power of 1, 8 to the power of 2, 8 to the power of 3, etc., etc. Okay? Now, the equation that we would set up here is we said, well, we need the total number of views to be 250,000. The base is how much we're being multiplied by every single time. Okay, every time I go up, it's being multiplied by 8. So that is the base of my exponent. We don't know how many days it's going to take. That's what we're trying to find out. And so in this case, I'm going to put x as my variable because that's what we don't know, right? Now, unfortunately, there's no way for us to simplify this, okay? The goal of this question was just to get you setting up the problem, okay? If you needed to, you could go ahead and we could continue to fill in this chart to see what the answer is going to be. 512 times 8 is 4,096. So that is 8 to the power of 4. On day 5, we're going to multiply by 8 again, get 32,768. On the 6th day, we're multiplying by 8 again. We get 262,144. We have successfully met the criteria. We've gotten over 250,000 views, and it has been in the first week, so therefore the video will go viral. Pretty cool. Okay, let's look at another one that we can actually solve. Miss Cluche's love of plants has turned to disaster. They're all infested with fungus gnats, and fungus gnats all just look like little fruit flies. Just stupider. The gnats seem to be getting worse by the day, and her research has shown that the number of gnats quadruples every 3 days. She is hopeful that killing them one by one will reduce the population enough, but is committed to buying a spray once the infestation is large enough for her. For her, large enough means that her 32 plants will have 512 gnats each. How long does it take before she needs to buy the spray? Okay. First, let's figure out how many gnats we're dealing with. I have 32 plants, and if each of them has 512 gnats, I would go 32 times 512, which is 16,384 gnats. Nasty. Okay? The other thing that we know is it's quadrupling every 3 days. So I'm being multiplied by 4, hint, hint, that's your base. But it's only every 3 days. So what does that look like? Let's set up our equation. We're trying to figure out when the total population is going to hit this, 16,384. So I take my base, which is 4, because it's being multiplied by 4. But it's happening only every 3 days. And so instead of my exponent being x, my exponent is going to be x divided by 3. Okay? What this means is it's happening 1/3 times per day. Or it takes 3 days for that to cover. Now we can go ahead and we can simplify, or we can solve using the exponent solving styles or strategies that we saw previously. Now, I don't know about you, but I do not know off the top of my head if 16,384 has 4 as a base, like if that's 4 to the power of something, okay? So one way that you can literally guess and check is you're going to open up your calculator. Let's see if I can find mine. I'm going to type in the number 16,384, and I'm going to start dividing by my ideal base. In this case, my ideal base is 4. I'm literally going to count on my fingers how many times it takes for me to get down until my answer is 1. Okay? Divided by 4. That's 1. 2, 3, 4, 5, 6, 7. 4 to the power of 7 is 16,384. Let me just double check. 4 to the power of 7. That's my magic number. Okay, go back to my problem here. 4 to the power of 7 is 4 to the power of x over 3. We now have the same base, so I can use my implies that arrow, get rid of my bases, and only deal with the exponents. And now I can rearrange. Normally to solve, multiply both sides by 3, 21 is equal to x. Because this is a word problem, I'm going to conclude with the therefore statement. Therefore, what was the question asking? How long does it take before she needs to buy the spray? So it takes 21 days before she needs to buy the spray. Okay, not so bad. Let's do one last one. Her efforts have failed. Ugh, I tried so hard to kill them one by one, but it just wasn't enough. The spray advertises that a single use will cut the number of live gnats in half. If she can only spray once per day, how many days will it take before the population is? Let's see what happened. Okay, our first question is asking us when it's going to be 1/8 of what it used to be. Our formula again, or the total gnats, was 16,384. But I only want 1/8 of that. So I need to figure out when the population, I'm going to do 16,384 divided by 8, which is 2,048. So I need to know when there's this many gnats. Okay? How many days is it going to take? So that's my answer. I'm trying to figure out when I get to 2,048. I'm starting at 16,384. And we've been told the population is cut in half. And so in the brackets here, I'm going to put this exponent, or this base of a half. And my exponent is going to be x, because we don't know how many times it needs to be applied for this to happen. Okay, now we're going to solve. I'm going to divide both sides by 16,384. 16,384, or sorry, 2,048 divided by 16,384 gets me to an eighth, is equal to 1 over 2 times x. And this makes sense because I was looking for 1/8 of the population. Now we're going to create the same base. We have 1 over 2 to the power of 3 is equal to 1 over 2 to the power of x. Same base now, we can imply that 3 is equal to x. Okay, so we have therefore, after 3 days, the population will be 1/8. Question B is asking, how many days is it going to take for us to get to 1 gnat? That would be remarkable. Okay? We're going to use the same formula because it's the same thing. We're still starting with 16,384, still being cut in half, still need to figure out how many days. Okay, this time, however, we only want there to be 1. So now I solve by dividing. We know that we want a base of a half or 2 if that's easier. So I'm literally going to use the guess and check strategy again to figure out if 16,384 is 2 to the power of something. 16,384 divided by 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, one more, 14. Double check that. 2 to the power of 14 is that magic number. So we're good here. 2 to the power of negative 14. And let me just rewrite this, our right-hand side, as 2 to the power of negative x. We can now jump to our implies that. Negative 14 is equal to negative x, not 8x, or 14 is x. So therefore, it takes 14 days for the population to reduce to 1 gnat. And I feel like I could probably take on that last one. Okay, so a lot of this was setting up the equation using the information that you've been provided, and then using our exponential law sort of knowledge here and solving exponential equations to manipulate them and to find what our variable is. Great work, everybody.